Hello all, welcome back to the channel and welcome to the course on integral calculus. So recall in the last lecture we have understood the concept of ILATE rule and try to understand some concept by using example. Now in this lecture we are going to discuss some more example before proceeding to the multiple parts rule, right? So let us see. The example which I have given you homework in the last lecture was x square upon x sin x plus cos x ka whole square, right? So now proceeding to solve it. First of all, let the I be equal to x square upon x sin x plus cos x complete square, right? So now just by seeing the observation we have to create the two functions, right? So try to observe the two functions by eliminating some terms or by bifurcating the terms in the particular order. So what I will do, like if I if I bifurcate this x as x into x divided by x sin x plus cos x, right? Right. So now I can write it as x sec x, right, into x cos x divided by x sin x plus cos x ka square dx, right? So what I have done, I have simply multiplied and divided the whole expression by cos x, right? Now what I will do, now this is as x cos x dx divided by x sin x plus cos x square. So now if we closely observe this x cos x upon x sin x plus cos x, so if I put x sin x plus cos x as t, then this would be x cos x plus minus sin x, right? Right? So this would be, so x sin x plus cos x, if I put it as t, then now apply the simply the product rule, right? So this is the UV rule. So this x remains same. Sin x differentiation is cos x plus this x ka 1 and sin x minus this cos x as sin x. So this would become x cos x and here we have the term, right? So what we will do? We will simply put it as dt by t square, right? dt by t square, right? So therefore this would be becoming minus 1 upon t. So this would be minus 1 upon x sin x plus cos x, right? So now our integration, the complete quotient integration would become x sec x into minus 1 upon x sin x plus cos x. So what we have done, we have simply simplified the integration so that we can apply the product rule, right? Okay. So now this is the first part minus. So we have taken the first function as, so if I take the first function we have taken as x sec x and second function as minus 1 upon t, right? So this is the first function. Second function's integration we have done already, dt by t square, right? So now minus integration of sec x plus x sec x tan x divided by x sin x plus cos x, right? Now what will we do? We will multiply this term as x sec x upon x sin x plus cos x plus integration of sec x common, right? And this is x sin x plus cos x, and here also if I take cos x common, then it becomes x sin x plus cos x, right? Because here we have tan x, right? So therefore this is So this say this cancel. This becomes, this is minus, huh? Here we take the sign. This is minus. So this is x sec x upon x sin x plus cos x plus integration sec square x dx, which is equal to minus x sec x upon x sin x plus cos x plus tan x plus ka c, right? So in this way we have solved the problem. Now let us see one more example and conclude the lecture, right? So integration log x divided by 1 plus log x square, right? Just give me a moment. Okay, so yeah, so integration log x upon 1 plus log x complete square dx. Now before putting it to by parts, let us closely observe the integration. Here we have log x square. So if I try to put something that log x st, then what will I get? 1 upon x dx is equals to dt, right? So 1 upon x dx. So then 1 upon x dx can be written as e power t dt, right? So ultimately our main goal is to what? Convert the expression into exponential form so that we can apply the ILATE root. Even also, even though you may ask that sir whether we can apply directly with the logarithmic function also, but if I see this function completely, then it becomes very much complex to understand and simplify the integration of the second function, right? So we have to put a function in such a form that the second integrable function is very much easy and we can directly apply the ILATE rule, right? So what will we do? We will we will substitute log x as t, right? Then what will be becoming? We will be have 1 upon x dx barabar dt, right? So then if I take dx, then this could be written as, because we have put log x as t, so this is e ki power log x, right? So e ki power log x, and e ki power log x is e ki power t dt, right? Because 1 is e ki power log x, right? 1 upon x, right? So x is e raised to power log x, and x can be written as e power log x, then it can be written as e power t dt. So now our integration would become e power t into t log x upon 1 plus t log x ka whole square, right? Now, now if I see, then e ki power t as it is. Now for the numerator part, if I closely observe, then I can write 1 plus t minus 1 divided by 1 plus t whole square, right? dt, right? This is the form. So now this becomes e power t 1 upon 1 plus t plus t minus 1, right? So if I took, instead of t minus 1, 1 upon 1 plus t whole square, then if I try to simplify using partial fraction, then I got the same result, right? So 1 plus t square plus 1, so this becomes 1 plus 2t plus t square minus 1, right? And this is also plus 1 plus t ऊपर जाके in the numerator case, so this becomes 2t minus t is t, so we got 1 plus t minus 1, right? So this way we can simplify it, right? So now if I got to know that this is the form which we have studied in the first lecture, that it is the form e power x fx plus f dash x form, and we have very well known that this integration is e power x fx, right? So this becomes e power t 1 upon 1 plus t plus c, right? So this becomes e power t means x into 1 plus log x, right? Plus ka c. So in this lecture we have seen the two problems basically. One is the homework question of a last lecture and the second was a new one. So please keep practicing and subscribe the channel for more such updates. Thank you so much and have a nice day.